Hi, everybody. In this video, I want to do some more practice with multiplying radicals. When we multiply radicals, we're still going to use the same processes of the distributive property and or the FOIL strategy. It's just that we have to now apply it to radicals as well. So for instance, in the first example, I'm going to take that root 3 and I'm going to go ahead and distribute it through to both groups, just like I would for a regular multiplication problem here. I'm just going to be a little bit more careful with that radical. There we go. So I have root 3 times 5, and then I have root 3 times root 30. Now, the thing with radicals when we multiply is that when outside things sort of stay outside and inside things stay inside, right? So for the first example here, this is 5 root 3. That 5 is outside the radical, so it's just going to tag along out front. But here, these are both under the radical. So I actually can combine them and use the multiplication idea here. So 3 times 30 is root 90. So again, things that are inside the radical when we're multiplying can go together. Things that are outside stay together for multiplication. Now, you would want to try to simplify this. Notice that root 90 is 9 times 10. That's one of the factors there. And 9 is a perfect square. So I am able to simplify it in this case. So this becomes 5 root 3. Here I'd have root 9 times root 10. So root 9 is 3, and then I can't really break down root 10 anymore, or it doesn't help me in any way. So this would be, for this particular case, my final answer. I can't combine these together because root 3 and root 10 are different radicals. And remember, we need to have the same radical to add or subtract. For the next one, I have two sort of binomial pieces being married, right? Being multiplied. So 2 terms and 2 terms. So I'm going to distribute twice, or you can use the FOIL method here, whichever strategy you prefer. So in either case, I'm going to start by taking that root 5 and multiplying it by the root 7, and then the root 5 by the 1. So I have root 5 times root 7 plus root 5 times 1. On the inside, I'm now working with the negative root 6. So I have negative root 6 times root 7, and then negative root 6 also times 1. If you can do this in your head, you're more than welcome. I find that roots are a little bit more complicated, so I'd like to write out the steps. Now, again, when things are in the radical, they're both square roots here, so I can just put them together. 7 times 5 is 35. This becomes root 35. 1 multiplied by anything is still that other value, so root 5. Here again, 6 and 7 are both under the radical, so I can make that minus root 42. And then here, 1 times root 6 is just going to go ahead and stay as root 6 in this case. Now for this example, I would see if I could combine any like terms. These are all different kinds of roots, so they're not going to go together. You could try breaking down the 35 and the 42, but you'll notice that there are no perfect squares there. So there's really nothing you can do. And this would end up being our final result here. Now, if your order is a little bit different, that's fine. Just make sure that the positive values are still positive, and then the 42 and the 6 for the roots, those are the negative ones. So if you multiply it in a different order, again, it's not a problem as long as you have all 4 pieces with the correct signs. For the next one, we have a square here. So I'm going to start by writing out the same thing twice. And then I'm going to do the same thing like the last problem and just start distributing or foiling. So I take 4 root 3 times 4 root 3, and then again times the minus 1. So I have 4 root 3 times 4 root 3, and then plus 4 root 3 times negative 1. On the inside, I have a negative 1 that I'm multiplying through. So negative 1 times 4 root 3, and then negative 1 times negative 1. Now for your roots, when you're multiplying, outside stuff goes together, inside stuff goes together. So 4 times 4 is 16. 3 times 3 is 9. Here, negative 1 times 4 is negative 4. I have the root 3. -1 times 4 is -4. I have the root 3. And then -1 times -1 is +1. Now root 9 is also 3. Oh, sorry, 3. So this becomes 16 times 3 here as well. And when you do that, you get 48. These are both like radicals because they both have a root 3. So I can put those together. -4 and -4, -4 is -8. So -8 root 3. I have a +1. And then finally, I'll put the 48 and the 1 together here. And I have 49 minus 8 root 3. So that would be my final answer for this case. All right. Again, if you're feeling pretty confident, this is a great time to pause the video and try the next one on your own. It's very similar to the last few. We're just going to do the same process of distributing or foiling it out. So let's go ahead. Here I have the root 2x being multiplied through first. So I have root 2x times root 2x, and then root 2x times 5. And then I'm going to take that -5 and multiply it through. So -5 times root 2x and -5 times 5. Now, when I'm multiplying, stuff on the inside goes together. So you have 2 times 2 is 4, and x times x is x squared. Here I have a 5 on the outside with root 2x. Here I have a -5 with root 2x, and 5 times 5 is 25. So I have a -25 at the end. Now, I'm going to assume that all of my variables are positive here. And root 4 is going to cancel nicely as 2, and then our root and our x squared are going to cancel to just x. If you don't know that your x is positive, you could put absolute value signs around it to clarify that. But I feel like in most cases, like 9 out of 10, we just assume that the x is positive, so we don't have to write the absolute value symbols. On the inside, you do have like terms here, but notice that you have a 5 and a -5, which is just 0. So these two terms are going to cancel out. And then you have a -25 at the end. Now, the reason you get this nice canceling in the middle, if you notice, you have the same exact terms here, except for one as a minus and one as a plus. So whenever you have that, you do get that nice canceling. So it does simplify pretty well here. All right, our last example here, another square. So I'm going to take my time and write this out. All right. And this one's a bit more complicated, but again, we're just going to take our time here. So I'm going to multiply that root x minus 3 first. So I have root x minus 3 times root x minus 3. And then I have plus root x minus 3 times 5. I'm going to multiply through by the 5. So I have 5 times root x minus 3, and then 5 times 5. Now, for the first case, again, they're both inside the root, so you end up multiplying it together. Now, what I want to show you is you end up with this. I'm not going to write this out and multiply it out because this is the same thing as having x minus 3 squared. And what happens is that radical and that square are going to cancel out. So when you have something more complicated on the inside, pause before you actually multiply everything out and think what's going on here. If you have a repeat term like this, or repeat group or factor, then we can write that as a square, and then now it will cancel with the square root. So let me move down here, and then I also have a plus 5, x minus 3, another plus 5, root x minus 3, and 5 times 5 is 25. So what I have left over from the first group is an x minus 3. These two terms, as I was saying, these are both the same kind of radical, so we can put them together. 5 plus 5 is 10. This becomes 10. And again, that radical just stays the same. And I'm finally just going to combine some like terms here. So I have an x, minus 3 and 25 is going to be positive 22. And then I have that 10 root x minus 3. There's really nothing else you can do here. If you have them in a different order, it's fine. But you should have an x, a plus 22, and a plus 10 root x minus 3 as your final answer. So for multiplying, it's just a matter of expanding and combining what we already know about the distributive property or foiling, and then just watching all those radical rules and being really careful. And then, of course, simplifying as much as we can.